All right, guys, welcome to day 6 of Unit 1, Math C. We're going to go ahead and talk about what we can do with normal distributions. So yesterday we talked about what a normal distribution is. Today we're going to find out why we like them and what we can use them for. So if you take a look, you see the following normal distribution. This is what we're going to use is we're going to call the empirical rule. So according to the empirical rule, it tells us that between one standard deviation of my mean, now that's what this little symbol means down here at the bottom. This is mean. That the way it's written, that's called mu. It's pronounced mu, like Mew, Mewtwo, Pokemon. So just like with math, as other things, we like to shorthand it, but we can't just do plain old regular m, because remember that's for slope. So we use the Greek letter mu, which stands for the mean or the average. So according to the empirical rule, 68% of my data will fall within plus or minus 1 standard deviation. So that means from here to here, I'll have 68% of my data that I've spoken about. So that's when I take my standard deviation and I add it to my mean. Remember, we talked about the standard deviation being the average between each data point. So if I take my mean and I add my standard deviation, or subtract my standard deviation once, I'll talk about 68% of that data. If I do it twice, so that same standard deviation, and I add it twice, so 1, 2, subtract it twice, I'll get within 2 standard deviations. And when I get within 2 standard deviations, I'm talking about 95% of my data. And lastly, within 3 standard deviations, I should be talking about 99.7% of my data. So I want to break something up real quick because it'll help us in our next problem. So if I draw that line, attempt to draw it straight, and I cut that in half, that's saying that I have 34%, of data here, and 34% of data here. Likewise, I have 13.5 in this chunk, and here, and then 2.35 in the last chunks. If you add all of those percentages together, you should equal, it's supposed to be 3.5, you should equal that 99.7%. If you want to double check my math, you are more than welcome to. Go ahead and pause the video. Okay, so what we're going to do now is we're going to create a normal distribution based on some information, and then we're going to use that to answer some questions. So the reaction times for a hand-eye coordination test administered to 1,800 teenagers are normally distributed with a mean of 0.35 seconds and a standard deviation of 0.05 seconds. So part A asks me to draw the normal distribution to illustrate the data. So I'm going to go ahead and draw this kind of large because I like to have enough room to write with. And I never do this side very well, so I'm going to try and fix that. Okay, so it's telling me that my mean is 0.35 seconds. So as we saw in the slide before, we're going to try and put our mean as close to the middle as we can. And we're going to label it. And then it tells us that my standard deviation is 0.05, which means that I'm going to go ahead and put those 3 standard deviations on here. So if I add 0.05 to my already 0.35, I'm at 0.40. And if I subtract that 0.05, I'm at 0.30. I want to make sure that I draw these about the same as what's over here. Again, I extended mine out a little bit because I write so big. So I know mine's a little bit skewed looking in general. But you got to think, that first part we're going to have 68% of my data covered. So I want to make sure I give it enough space. So that's plus or minus 1 standard deviation. So now I need to do plus or minus 2. So I'm going to go ahead and add another another 0.05 to that 0.4. So that puts me at 0.45. And likewise, I'm going to subtract another 0.05. So from red line to red line, I'm at 2 standard deviations of my data. If you take a look back, that should be about 95%. And one more time, puts me at 0.5 and 0.2. Again, trying to make this look as close to as what I already have. Part B, about how many teens had a reaction time between 0.25 and 0.45. Okay, well, if you take a look, 0.25 and 0.45 are within 2 standard deviations of my mean. Remember, we added or subtracted that standard deviation twice from my original mean. So, according to the slide before, within 2 standard deviations is 95%. So we're going to use that here. So 95%, now remember, whenever we work with percents, we change them into decimals before we do anything with them. Now I'm trying to find how many. So I'm going to take 95% of my total teenagers, and I'm told I have 1,800. So I'm going to take 0.95 times 1,800. And I'm going to come up with 1,710 teenagers. All right, let's take a look at part C. What percentage of teenagers had a reaction time greater than 0.4 seconds? Okay, so 0.4 is 1 standard deviation and above. So if I go back a slide, and this is why I put these numbers in for you. Here's my 1 standard deviation. So I want to add these two together. So I'm going to go ahead and take I'm going to take 13.5% plus 2.35%. And that's going to give me 15.85%. Okay, so part D. What percent of teenagers had reaction time less than 0.27 seconds? Well, 0.27 is about right here. I can't determine how many standard deviations away that is because it's not a full standard deviation, and it's not on there. It's not a nice pretty answer. So we can't find this out yet. We don't know. No idea on this one. Can't answer. NA. NP, more like not possible. I don't have enough info. You know that handy dandy little sheet I gave you? That's where this comes in. We're going to find the z-score. So this is how we're going to find those numbers that aren't on my normal distribution chart. So what we're going to do to find my z, now I'm going to call this my z chart. So that nice little chart you have, you can label as your z. Oops, I forgot to change that formula. Sorry about that. I'm going to call that my z chart. So if I ever refer to my z chart, that's what I'm talking about. So if you want to label that, you're more than welcome to. So to find that number, to look at my z chart, I'm going to take the number I'm looking for minus the mean I'm giving divided by my standard deviation. And then I'm going to look for that number on my z chart. Okay, let's go ahead and take a look at this next example. So we're going to more than likely need to use that z chart, so don't put it away yet. Miss Sung gave a test in her math class. Her scores were normally distributed with a mean of 85 and standard deviation of 3. So part A, go ahead and draw that normal distribution curve. Again, I don't draw mine very straight. So we said we had a mean of 85. So one standard deviation away, we're going to add 3. So 88. And subtract 3. So 82. Add 3 more to get 91. Subtract 3 more to get 79. Add 3 more to get 94. Subtract 3 more to get 76. Okay, what percent of students would you expect to score between 82 and 88%? Well, according to my first page of notes, if I went ahead and used that, it would be about 68%. Now remember, that's kind of just a rough estimate. So let's get used to using our z-chart and making sure we fully get the actual percentage. So I'm going to go back a slide for a moment. So we're going to go ahead and use our z. So we're going to take x, the number we're looking for, minus our mean, divided by standard deviation. So let's look at the 88% first. So I'm going to take 88 minus 85 divided by 3. Come up with 1. Okay, we're going to use that 1 in a second, so just keep it there. Don't forget about it. Next, we're going to use 82. So 82 minus 85 divided by 3. To come up with a -1. Now, this is where we're going to look for our z-charts. So when I say z of 1, that's me telling you we're going to look for the number on my z-chart of 1 minus the z of -1. Okay, well, let's learn how to read that chart. So here's my chart. We are looking for z of 1 first. So here is, to read this, you're going to go down. So I have 1.00. So I'm going to look for 1.0, and then I'm going to go to the right until it's 1.00. So I get 0.8413. Can blow this up for a second. Again, I went down my z-chart till I found 1.0, and I'm going to 0.00, which is 0.8413. Now I'm going to take that number minus the z of my -1. So let's go back to that chart. My negatives are on the other side. Again, I'm looking for -1.00. We don't want any extras. So I'm going to go down my z until I find -1. It's all the way over down here. And I want -1.00. So it's going to be this number right here. So that 0.1587. So when you go ahead and subtract those 2 decimals, you get 0.6826, but we want to turn that back into a percent. So if you turn that one back into a percent, it gets you 68.26%. So the difference here between using that first example like we had and using my z-score is that I become more accurate. And just like always with math class, we want to be as accurate as we possibly can. So 68.26% compared to just 68. Okay, next we're going to look for finding the percent of scoring over 91. So we are going to take 91, because that's the number I'm looking for, minus my average or my mean, divided by my standard deviation. So the number you should get here should be 2. So now I'm going to go out on my z-chart. I'm going to find the z of 2. Okay. So mine's on my second page. Here's my z's. Oops, can't really see that. Here's my z's up at the top. I'm going to look for 2. It's 2.00. So 2.00 is 0.9772. Now, if I turn this straight into a percent, don't write this down yet. it would turn into 97.72%. Is that how many people actually score over 91? Think about it. If I scroll back up for a minute, here's 91. Do I have 97% of people from here on over? No. What that's saying is I have 97% from here all the way to here. So I have this right now that I just calculated. Do I want all that? No, I want this stuff over here. Well, if you think about it, our distributions are 100% roughly. So what I'm going to do with that 0.9772 is I'm going to take 1 minus that. Because remember, 100% as a decimal is just 1. It gives me 0.0228, which gives me 2.28%. Well, I'm getting too close to the edge, just like with my smartboard. I run out of room. Let me take 1 minus 0.9772. And that gives me that 2.28%. Now, doesn't that sound more realistic on those who score over a 91% based on that image above? I thought so too. Trying to clean that up a little bit. Okay, last part. What percent do you expect to score below 80? Okay, so because we're going below 80, where you can just go ahead and approach part D the way we had started to approach part B. Because remember, we're going to go from 0 onward. So we want to stop when we get to that 80. So we're in the right track by just using our normal z-score. So we're going to go ahead and take my value I'm looking for, in this case 80. We're going to subtract my mean, which is 85. And then I'm going to divide by that standard deviation. So I should get negative 1.67. So I'm going to go ahead and find the z of negative 1.67. So let me pull that page up. Now, if you notice, I'm still on the positive, so I need to go to the negative side. Oops, mine needs to go up. My apologies. So this one's a little bit different than the one before. We have negative 1.67. So I'm going to look for negative 1.6. And then this is 0.60, 0.601, 602, 3, 4, 5, 6, 7. So the value I'm looking for is 0.0475. So again, I read down the 1.6, looked for it, came across this section, and then had to go to the right until I got to underneath the 0.07. So I'm basically adding 1.6 plus 0.07 together. So I'm reading the chart that way. So that's how you read these. So I get 0.0475. Which, when you turn it into a percent, is just 4.75%. That's all I've got. Have a good day.